Okay, so now we are going to do this end-to-end transmission. So we want to send a message from a process running in this host H1 in this network 143.132.0.0 to a process running in host H2 on this network 190.34.0.0. So these are what you are given with are the IP addresses of the end host as well as the router interfaces as well as the MAC addresses, the hardware addresses of all the network interfaces. So at this host H1, we have the data that needs to be sent from the process. The source process is running at port 21 and the destination process is running at port 32 on this machine. The source is running on this machine. Yes, so we send down from the application layer to the transport layer where we basically add or prefix the transport layer header with the data, and the main ingredients of the transport layer header that we are interested here are the port numbers. The source port number indicating the identifying the process running on the sending host, and the destination port number identifying the process running on the destination host. Okay, so the transport layer header along with the data is called the segment. Now, it is sent down to the network layer. We attach the IP header or the network layer header. In general, you can call like that. The IP header basically has several fields. The things that are important to us now are the source and destination IP addresses. The source IP address indicates the IP address of the sending host, the ultimate sending host, and host, and destination IP address is the IP address of the ultimate end host. Okay, and so the IP header along with the segment is what is called as the datagram. It's sent down to the data link layer or the network interface layer where you attach the frame header that has the hardware addresses. So if I want to send from H1 to H2, I need to now know what's the next hop I need to send from here to here. So that's actually decided at the network layer by the routing protocol and is informed to the data link layer. So the next hop is found to be R1. So I need to send the packet to interface 1 of R1. So for that, I need to send from H1 this interface to interface 1 of R1. So I need to use the MAC address corresponding to hardware, the network, the host H1 on this interface, and then the MAC address corresponding to this interface 1 of R1. So I'll use the corresponding to hardware addresses. So this is the hardware address for the network interface for H1, and this is the hardware address for the interface 1 of R1. Okay. So I'll send the frame header along the data is called the frame and send it on the physical layer, encode the now the data in terms of your signals and send it to the router. So at interface 1 of R1, it's going to get this frame, and the frame header is actually going to be removed and sent to the network layer for further processing. So the routing protocol will find out if order to send to this host 190.34.IP address, you need to forward it to this next hop, router R2. So you need to now know the MAC address or hardware address to send to interface 1 of R2 from interface 2 of R1. So you attach now a new frame header that corresponds to interface 2R1 here, and this is interface 1R2. So these two are the new MAC addresses that are going to have, not in the original frame. Remember, it goes up to the network layer and then comes down. So we're going to basically attach a new frame header. Okay, and send it down to R2. At R2, now we are going to remove this frame header and send it to R3. So you need to attach a new frame header that has interface 2 of R2 and interface 1 of R3 as the MAC addresses. Send to R3. At R3, you need to send it to host 2. So you attach the MAC address of interface 2 of R3 and host 2 MAC address. So once the packet goes to host 2, the frame header is again removed and sent to the network layer. So here we identify that the packet is indeed addressed to this machine because the IP address will correspond to that host H2. So now you send to the transport layer where you queue that packet segment basically in the queue for the process running on that port number, and once that process is scheduled to run, the segment will be processed, and then the data will be forwarded to the application layer. So you notice here the transport layer header is not even looked at by any of the headers. The IP header or the network layer header is only looked at by the routers just to find out what's the destination IP address so that the packet can be forwarded to the destination network. The structural changes that happen only at the frame header, where you remove the frame header on the incoming frame and attach a new frame header to the outgoing frame. Okay, so we call the top two layers, the application layer and the transport layer, as end-to-end layers because the data and the transport layer header are not even looked at. So what are being looked at? The network layer header and the frame header, which goes through a change. So the bottom three layers, the network layer, data link layer, of course, in the physical layer, are called the host-to-host layers because they play some role in the hop-by-hop transmission from one network to another network. Okay, so this leads us to this terminology where we have the segment is application data plus the transport layer header. The datagram is the segment plus the network layer header, and then the frame is the network layer header plus the link layer header or the frame header. Okay, so let's look at the TCP/IP protocol stack. So these are the 5 layers of the TCP/IP protocol stack. From top to bottom, you can see application, transport, internet layer, the network layer, and then the network interface or the data link layer, and the physical layer. Okay. So the application layer is responsible for 3 different things. It is responsible for the actual application data, trying to run all these protocols to generate the data and transmit them. And then also it is, if needed, responsible for the presentation, the different formats, translation, everything. And then also if you need to log into the other machine and before you can start sending data, you need to worry about establishing a session, the password management and everything. All these things are taken care of at the application level. At the transport layer, you worry about reliability because if you, for example, want to download a file, you want to make sure every bit of the file at the sender side reaches the receiver. So you worry more about reliability and all the bookkeeping issues about how many bytes have been received, what bytes need to yet come, and so on are kept track at the transport layer. Okay? You also want to make sure that the sender doesn't overflow the receiver by sending too much of information in a short amount of time. So all these flow control issues are also maintained in transport layer. And then in addition, we also maintain the congestion control issues because in addition to making sure that you are not overflowing the receiver, the sender also wants to make sure that it's not overflowing the internet because you're going to send your packets through a sequence of networks. You want to make sure that you are sending only what the internet can handle. Then the internet layer or the network layer is responsible for network to network transmission of your packet. And the network interface layer or the link layer is responsible for transmitting the packet within a network, like we did from one network here to from this interface to this interface. So that's the functionality of the network interface layer, from sending from one interface physically to the next interface. And then the physical layer is used to encode the signals with the data that you want to send. Now, the ISO-OSI model is just like a broken down version of the application layer where you have the session layer, presentation layer, application layer, representing the top 3 layers. So it's only difference in the top layer. The application layer in the TCP/IP protocol stack is broken down into these 3 layers. Okay, so as we discussed in class, we need a header for each of these layers. So if we add all the 7 layers, we need this header. So to avoid the overhead, as well as we are not doing always session management login to every application that we communicate, as well as we are not doing the presentation management at for every communication, right? So only when needed, we need all these things. So that can be taken care of in application layer itself. And the bottom 4 layers are pretty much the same, just the difference in terminology. Here we call it as a data link layer for the network interface layer, and we call network layer here for the internet layer and the TCP/IP protocol stack. Okay. So we start with this.